Let's implement some counters using these T flip-flops, and let's connect them in this fashion over here. So 4 flip-flops, T flip-flops connected in series with the clock connected together, so asynchronous. Let's bring our Logisim and let's build this. Let's go over gates, let's go over memory, and here we have our T flip-flops, and I want 4 of those, so here you go. Oh. All right. Good. And let's connect that. So notice that the clock is connected all together, and the clock on these flip-flops here is on the top. So I'm going to give some space because we have some logic in between them, here and here. And let's connect the clocks. So I'm going to use button here for the clocks and connect these. Go up to the last one. Here you go. And the clocks of these guys connect up. Great. So clocks connected. And now I'm going to, so the input of this one is 1. So I'm going to have a pin 1, notary state. Let's put it here. This is going to be my pin 1. Perfect. Let's put it to 1. And now let's connect the rest. So Q connects to the T of the first one. So this one goes directly to that. So I go here and connect directly to that one. And the second one here, we have an AND gate. So let's grab our gate AND, which has 2 inputs. Perfect. Connects to the T, and the Q connects to that one, and this one connects to your T. And we have another gate over here, an AND gate, and 2 inputs already there. I'm going to put it here. I'm going to adjust this clock over here just a little bit more, make it a little bit tighter, and connect this guy here, Q over here, and the output of this connects. Perfect. Now let's put our labels to have our bits coming out. I'm going to have tunnel facing north, and I have one here, one here, one here, and one here. So this one is going to be my Q3. This one is going to be my Q2. This one my Q1. And at last, this one my Q0. And let's see if this works. Let's see if this counts. Let's pay attention to the value that it's over here, 0, 0. Right now it's all 0. So if I give a clock, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Nice, my counter is working with these T flip-flops. Let's make these a little bit more useful. Let's add, let's go here to the input and output. Let's add hexa digit display, which is going to show you your values in hexa. So you give 4 bits over here, and it shows you the values from 0 to F. So let's go pick up our wiring probe, put it here, and I'm going to count. This is going to receive 4 bits. I'm going to call this my count. And the second input over here, this is to control that dot over there. I don't care about that right now. Now all I need to do is to gather these 4 bits together and form a count. So if I go on my splitter, let's point it to the other side, And if I say that I have 4 bits, now all I need to do is connect, let's face this one to est. This is going to be my count, 4 bits count, and these ones are going to be those queues. So I go here, tunnel facing east, and I'm going to place them here. All right, let's make them here. Q0, Q1, Q2, and the most significant bit. So Q3, Q2, Q1, and Q0. And this should be ready to work. Let's see. If I go here, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Perfect. Let's make these counting automatic, so I don't need to press the button. I have my clock, put my clock, connect my clock over there. I go to simulate. I'm going to put a frequency of 2 Hertz, which is going to count every second. Going to enable, and here you go, counting every second in an automatic way. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's pretty cool. All right, let's just stop this clock. Let me see, what other parameters do you have here? You have preset, enable and disable, and also a clear. Pretty cool. We can clear all these. So let's clear them. So if I want to clear them to start new, I'm going to use the button north. I go here and I put my button, which is clear. All I need to do is now connect all the clears to that button. And if I press resets, let's just have the tick every second, and every time that I press the button, clears and it starts the counter again. Perfect. All right, let's stop the tick. And at last, let's say that I want to count just up to a certain number. Let's say that I want to count only up to, let's say 9. All right, so what do I do? Well, to count up to 9, I know that in binary 9 is 1001. So if I have that combination, all I need to do is to, whenever that combination happens, I do a clear so it resets. All right, but the 9, I still want to count the 9, so I'm going up to 10 and then reset. So if I pull a AND gate and I say that I have 4 inputs, and those inputs are going to be these queues. So let's connect those. Before we do that, let's just connect the output, which is easier. So let's create here a tunnel facing north, which is going to be, instead of this button, we're going to create that thing that says clear or reset, whatever you want to call. And here facing east, facing west, and I call this one clear. So what is the combination of inputs that I need to have in order to clear my counter? So if I want to clear count up 0 to 9, 9 is still displayed. So when I get 10, I clear. 10 is 1, 0, 1, 0. So I'm going to have, this one is going to be 1, and my Q3 is going to be 1. That doesn't change. But my Q2 and Q0 needs to be 0. So if I pick up my NOT gate and I negate these two, so 1, 0, 1, 0 is 10. If I run my clock, whenever I reach to 10, so 4, 5, 6, 7, 8, 9 is still good, but 10 clears, resets the timer, and keeps going. And here you go. You have here a very simple version of a clock that just counts up to 0 to 9, and you can change this combination for whatever you want so the AND gate works properly and clears your counter. Give it a try, play around with it. Notice on what happens when I put a 0 over here. It starts counting just the odd numbers, which is pretty cool. Play around, go to your slides and implement other circuits and with Logisim and see what happens.